Good morning, everyone. So, we will continue our journey. Is matter around us pure? In that, we discussed it is not pure, it is in the mixture form. When it is in the mixture form, can we separate? How to separate? On what ground? What are the methods? All these points we discussed in our previous sessions. So, one important statement I want to repeat: selection of a method depends on the nature of the components which are present in a mixture and nature of mixture itself, and the property and the characteristics properties of components as well as mixture. We select a suitable method so that our separation technique or our separation method becomes very easy. See, we have to see two methods, two important words. So, easy and convenient and economical. Method should be easy, and we should feel that it is a convenient to us. And second is economical method, means let us not spend more money on that method. So with the least money, with the least energy, with the least effort, with the least physical labor, so everything least, so that our method becomes successful and the result is good. That is the purpose behind every activity or the every experiment. But there are certain experiments, there are certain activities, they require some costly method. No problem, that time government will take care. So for example, research work or the space work, that time government is there. So to help, if you have taken some interesting chapters to study in future, so there is a government, there are some examination. If you pass those examination, then government will give money in the form of stipend, and they will sponsor you. Many companies are there, many governments are, they will sponsor. So your all expenditure, so that you can give, you can work and you will give good result. Ultimately, you are our asset, nation's asset. Okay, so with this, let us start today's session. Today we are going to discuss one more method, that is called sublimation. Here sublime is the word. Sublime means to become gas, to become, to go to the vapor state, or to go to the gaseous state, or to become more volatile. So he is becoming sublime, we say, no. So that means there are some person, they don't control the anger, always in the angry mood, always in the unhappy mood. Okay, not flexible, always rigid, so not ready to adjust. So all these such, for such persons, in psychology we use the word that person is highly sublime. Suddenly he becomes anger. So it is not good. So but in the chemistry, sublime means what? So normal method or the normal thinking or the normal route is what? Any solid, when we supply heat energy, first it becomes liquid, then if you continue heating, it becomes gas. So this is the normal route or the general route we have seen. But in some cases, selected cases, examples are very few, countable examples. In those cases, what happens? By heating certain solids, they directly go to the gaseous state, vapor state. This we have learnt in the sixth class. Okay, so small introduction was there about this word in the sixth class. Now today we are learning in detail. So that method is called what? Sublimation. It is a direct conversion from solid to the gas. Why only certain elements will go directly from solid to the gaseous state? So this we can explain on the 12th class ground. There is one chapter known as states of matter in detail. You are going to study in the 12th class chemistry. So there we are going to learn different types of forces which are there in the solid state. So some I will name just for your additional knowledge. It is not there for your syllabus. So there are London forces, there are van der Waals forces, okay, there are dipole forces. So there are many. All those forces are called interparticle force of attraction. It is a general phrase we use. Interparticle force of attraction. That means solids are made up of what? Small particles. So between the particles there is a force. Which force? Attractive force, or we can say using the physics knowledge, cohesive force. What is cohesive? To bring together. Okay, when atoms come together, so to bring we require some condition, no? So that condition is what? That is a force condition. So it is a force which is bringing Why the force operates? Again, it depends upon what the charge it will possess, or the electron, what we are going to study in our ninth class only in the last chapter. So all those we study when time comes. So now time being what? So because of some intermolecular force of attraction, so variety of intermolecular force of attraction are there. So in these cases where we study sublimation, no, so those solids are called as what? Sublime solids. Sublime solids are solids where intermolecular force is very weak, being a solid. That is important. Normally, in the solid state, intermolecular force or the interparticle force of attraction is the strongest, and in the liquid, it is moderate, and in the gases, it is very weak. That's why they keep moving in random motion. So, wherever they are, so in whatever container they always keep moving. That is called as the constant random motion, or the constant zigzag motion, or this motion is discovered by Robert Brown. So therefore we call it as what? Brownian movement, or the Brownian motion. This I gave you a small idea under the chapter Tyndall effect. Okay, so all these are there. Only thing is we have to find out the reason, we have to find out the cause. So why they are like this. So in the case of certain special solids, intermolecular force is very weak. So because of that, the moment you supply heat energy, they suddenly separate. Okay, they go to the vapor state. And best example in a day-to-day life, you have seen, or you might have experienced, is what? It is a camphor. In Kannada, we say it is a karpur. Okay, so whenever we use karpur for the puja purpose, to worship God, so for the arti purpose, so when we burn that karpur, suddenly it goes to the vapor state. In the same way, you might have seen in the cupboard or in the almirah, okay, where book racks are there, clothes are there. There we will keep naphthalene balls, because sometimes cockroach may come, some other insects may come. So to avoid all those insects or the cockroaches, where we keep what? Clothes and the books, we keep naphthalene balls. So naphthalene balls, you just observe, you might have observed already. So when we keep today, after 1 week or after 1 month, it disappears on its own. So that means naphthalene. So in Hindi or in Kannada, it is what? It is a dambar goli. Okay. So that is what? In chemistry, its chemical name is what? Naphthalene. So in the form of naphthalene square, naphthalene ball. So in different shapes, they are available in the market. So naphthalene ball also comes under the sublime solid, and ammonium chloride, and naphthalene, and anthracene. Okay. Camphor, iodine. So there are examples are there. So all those examples are comes under the category sublime solids. So when the sublime solids are there, it is easy to separate. For example, I am having sand and the iodine. Okay, I am having sand and the iodine. So how to separate? Sand is not a sublime solid. I told you, selection of a method depends upon the nature or the properties of the components present in that mixture. Okay, so therefore here we have two components. One is a sand and the other one is iodine. So sand is not sublime solid, whereas iodine is a sublime solid. So therefore straight away we select the sublimation method. So when we take the mixture of sand and the iodine in the china dish or the crucible, so when we heat that crucible or the china dish, so what happens? It is the iodine directly goes from solid to the gaseous state and escapes, and thereby what is left in the dish? It is sand. So in this way, by using the sublimation technique, we separate iodine from the water mixture. But here iodine escaped to the atmosphere. But how to collect it? So for this purpose, you have to make some extra arrangement. So first to take the mixture of iodine and the sand in the china dish, keep it on the tripod stand. Okay, be ready with a Bunsen burner. Then you take one glass funnel or normal funnel. Okay, if glass funnel is not available, you take normal funnel, but not a plastic funnel. Either you can go for the wooden funnel. Nowadays, I don't know. In the earlier, we were having a wooden funnel in the laboratory, but now they have replaced by the plastic funnels. So now, for the wherever heat is there, we don't prescribe. We don't use plastic funnel because plastic melts. So either you can use a glass funnel, or you can use wooden funnel if it is available, or a metallic funnel. So anyone which is heat resistant. Okay. So that funnel you use, and the that mouth is covered with the cotton wool, so that the iodine gas or iodine vapors will not escape. So this all arrangement why? To collect iodine. So after doing all these arrangements, now be ready. So over the China dish, keep the funnel in the inverted position. Okay. So it is shown in the diagram. Please go through. You have to concentrate diagram as well as what I am explaining. So keep the funnel in the inverted position, and now start ready. Okay. Start heating. So the moment you start heating, so whether it is iodine, whether it is ammonium chloride, whether it is camphor, so any solid which is sublime solid, it will escape, okay, in the form of vapor, and it collects, because see there, as long as it is on the China dish, it is in the hot condition. So it will become what? Vapor. Once it leaves that area, goes to the upper area, upper area is not so hot. Okay. So suddenly it becomes solid. So that's why it collects where in the inner side of the funnel, that is shown by using the arrow mark. Okay, that you can see that ammonium chloride here I have taken. So that ammonium chloride is deposits. Then take out the funnel. So take out the funnel, and using the your finger you can take out all that white color ammonium chloride or violet color iodine, whichever you have taken, and you can separate aramse. Okay. So in this way, by using the sublimation method for the sublime solids, we can separate easily the mixture. But here we go for the simple mixture. Okay. In higher class, there are mixtures. There are examples for mixtures where we have complex mixtures. So 3 components, 4 components, 5 components, and many components.
Sir,
So when we have
sir,
many components,
carbon dioxide is also sublime, na sir?
it will come soon after this discussion. You will going to see that only. Okay. So right. So it depends upon how many components are there and what are their nature. So we go for one method or two methods or the many methods. So but in the ninth class we discuss only mixtures where we have only two components. They are called as binary mixture. Bi for two, di for two. All these are Greek, Latin, Roman literature we use till today because of their contribution. Okay. So the mixture which is made by only two components, that mixture is called as what? Binary mixture. Okay. Only binary mixture is there for your syllabus in ninth class, and in the 12th also binary at the most one extra will be there, and in the higher class graduation and in the post graduation you are going to have the many mixtures. There you learn higher techniques how to separate. Okay. Now time being we go for binary mixture. Now you see this one. Next, please see. Yeah. So here is the what you discuss. So what is this here? All that you will come now. Hmm? Yeah. Yeah. Okay. So this is our topic of discussion, and see here your example. Your example. Okay. So this is what solid carbon dioxide.
Dry ice.
Dry. Okay, exactly. Why it is called as dry ice? See, because when we
Sir,
cool, when we solidify,
already completed.
when we solidify carbon dioxide gas, so we have to apply low temperature and the high pressure. That we learn in the higher class once again. So that time, so it gives cooling effect. One, okay, but it is not wet. What we see in the normal ice, no. So whenever we touch normal ice, it is water only. It is wet. But this is it because it is very cold. So ice word is used here. Okay, but it is a dry. So it looks like ice. That's why we are using the word dry. So this is no way connected to the ice. Okay, ice is different. This is different. This is just to feel, to experience from the past. So we are using all those. So dry ice is there. So sublimation. You can see this is naphthalene ball kept in the almirah where clothes are washed. Clothes
Sir,
are
is
there.
dry ice poisonous for women, sir?
No, 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 not poisonous. Okay, it is not a poisonous. Hmm? It is harmful but not poisonous. Okay. Uh, so
Sir, if we take internally dry ice, what will happen, sir?
why you take first? Tell me. Why you take?
No, sir, by mistakenly if it happens.
No, by mistake. Carbon. Our body metabolism is not meant for the carbon dioxide. That's why we are giving out now, exhaling. So when we are exhaling CO2, so why you take then? So carbon dioxide is not at all good for our body mechanism, for the physiology of our body. Okay, so that's why in chemistry precautions are must on every bottle of a chemical. Okay, so everywhere, so we write some precautions. So whenever you are dealing with the chemicals, whenever you are discussing chemistry, that time precautions are must. So unless you don't take precautions, don't enter the laboratory. It may give some side effects, or it may be what dangerous also sometimes. Therefore, kindly don't play with chemicals unless you know their property. So this is the naphthalene ball we keep in the almirah, and in the due course they disappear. See, this is the fingerprint. Nowadays, latest techniques are there in the forensic department. So where we check their DNA. So thief will say, murder, that one who has murdered, he will say, I am not murdered, so I am not a culprit. But when they go to the DNA test, final test, see, DNA test is the final test. Okay, they collect all the evidences. So by using all those evidences, if we are not in a position to say that he is a culprit, he is a criminal, then finally court will order DNA test that we learn in the higher class. Special branch is there, that is called BSc in forensic chemistry. Okay, so there we take out the body what parts, and especially the fingerprint. Okay, some body fluid also we collect. So they undergo some test. So here iodine vapors are allowed to fall on the finger. So that print is taken, that is analyzed. So what kind of circles are there? So every human beings are different DNA. Okay, no two persons are same. That is there in the biochemistry or the microbiology. So by analyzing fingerprint, certainly they will come to that this person has done the mistake. Okay, this is what we learn using the vapors of iodine. That means what I'm saying here, I'm not saying that forensic department here. I'm saying sublimation technique is used in the what forensic chemistry. See here, snow on its own is undergoing sublimation. Okay, that we can see on the top of Himalaya or the Mount Everest. Okay,
The
so
snow
there.
will be by
uh,
process of sublimation, sir.
no, it is forms. When snow forms under a very cold condition, it keeps changing. Okay, it keeps changing to water vapor to the snow, snow to water vapor. So it is the low temperature and the pressure matters at that time. Okay, we can't say nature, what are the conditions. Okay, so on its own they are taking place. So due to the temperature and the pressure factors, but snow undergoes sublimation after forming. This is what print you will take out now. Nowadays you are taking print of photo print, image you will take out, or the some letters you will type and take out print out. So normal printouts nowadays we see now in some area they take out the what iodine or the sublimation paper is there. So it is spread inside the printer machine. So all those chemicals are made out of the sublime solids. So again you learn in the what semiconductor technology about this knowledge. Have an idea only, just have an idea. Now this is what psychological sublimation. Whenever a person is in the not good mood or sad, or if he is scolded by his friends or a teacher or authorities or anybody in the parents, okay, so that time he will feel bad. So immediately you have to go for walking, or you have to listen to the music, or you have to go to the some other friend's house, or just on your own you go for some different activities. You change that place. Okay, so that means the whatever your thoughts are in the sublime mood, sublime condition, no, that will cool. That means you will become normal. That is the idea behind. Okay, so the idea behind this picture is what, so whenever we are in the sublime condition in terms of thought, in terms of mood, due to some reasons in the family or in the society, okay, that time best is to go for the walk, to listen to the music, to cut the joke with someone if you are with whom you are comfortable, or
Sir,
let
your
us
voice is coming less.
you are go on your own. Okay, on your own you go for a walk, right? So all these just to relax yourself. Okay, right? So this is this
Your
topic.
voice is coming slowly.
Wait, I am doing that only. Wait, have a patience. We are becoming sublime. The same topic I'm saying, the same topic I'm saying, hey, you have to wait, no? So you are far away, I'm here. So there are some problems are there, so that you have to wait. So for some it is clear, so for some it is not clear. That time you have to wait patiently. So don't become sublime what I am showing the slide. Okay. Then you please go for the walk after the class. Okay. Right. So all these are sublimation conditions. Yeah. Now please see this one. It is a special technique we are using in chemistry also. But this technique we don't learn in detail. This technique we don't learn in detail. So just it is a introduction of the topic, that is chromatography. Okay. So chro means color. Graphy is a technique of separation. Okay. So chromatography earlier we were using to separate the color components. Okay. For example, to separate the green pigment from the leaf and to separate the color component from the ink. So for all these we are using chromatography. But now chromatography has undergone tremendous change. Okay. There are variety of methods available in the chromatography. So paper chromatography, thin layer chromatography. So the chapter itself is a very big chapter, is at the higher level. So every big book, many books are available on the chromatography. But now we will not go to that level where let us have an idea. So to know whether the ink is single compound or what is single or many. So to see that one, we go for the chromatography. So what you will do? So here in short I will explain. Chromatography means we take a normal filter paper, what we see in the chemistry laboratory. Hmm? So that filter paper we take and we apply one chemical on that filter paper. What is that chemical? That chemical is what? That chemical is a stationary phase. Phase is, it is a state. So we select such a chemical where ink can flow, ink can move. Okay. So we, again I am repeating, separation method depends on the nature of the components. Okay. So depend upon the nature. So we select such a chemical where we apply. We apply to the spoon. Okay, like that we apply on the paper, like it's like a gel. We make it in the form of a gel, like a paste. Then we apply on the filter paper. Okay. So after applying the filter paper, that is kept in a beaker, that is kept in the beaker, and in the beaker there is one more liquid. Okay, that is what? A solvent. Okay, so that will move throughout the filter paper. So when we keep the filter paper in the beaker, at the bottom here liquid is there, solvent is there, so slowly it moves. So because it is moving, so this phase is called what? Mobile phase. So totally there are two phases in the chromatography. One is a stationary phase and the other one is what? Mobile phase. What is a stationary phase? Stationary phase is what? The one chemical we applied on the filter paper, okay, or the normal paper which can absorb water, and the chemical which is moving, that is called what? Moving chemical or the mobile phase. So these words we use in the chromatography. So two phases, stationary and the mobile. Stationary we apply on the filter paper, and the mobile we select such a solvent so it should move freely into the on the surface of filter paper. Okay, so all these elements we make, then on the filter paper, so at the bottom we draw one line using the pencil. Okay, so on the line, so we keep one drop of our ink just to see. So when we keep a drop of ink and that filter paper is slowly inserted into the solvent which is in the beaker. You see the diagram also. Okay. So in the beaker, in such a way that pencil mark is just above the that solvent, using stand, clip, all that you have to make. Okay, so using all those small clips and the are important stand. So that filter paper should be in such a way that only little the bottom around 5%, 10% will be in the solvent. That is what, that is up to the pencil mark what you have made. So pencil mark should be above the surface of the solvent. That alignment you have to make. Okay, so then just wait. So what happens here? Because that solvent is touching the bottom of the filter paper now. So due to the surface tension, okay, technique is there now in the physics. So that will start moving. It will start moving. So when the solvent comes in contact with the ink you have kept on the drop, that small drop is there now that kept on the filter paper, then there starts the separation, because already we have applied one chemical on the filter paper which is known as what? Stationary phase. Okay. So one more chemical is going now moving from the bottom to the top on the filter paper. That is called mobile phase. This moving chemical or the solvent or the mobile phase will take the components which are present in the solvent. Okay. So the one which is not soluble or mixing with the solvent will be there only at the bottom only. Whereas the one which is soluble, so it will go towards the upper side. You can see in the diagram, the many spots are available. So depend upon the solubility, depend upon the mixing, or depend upon one more word is in the chromatography, that is called retention. Okay. So depend upon the retention capacity, how much it is retaining. Okay. So we also have the retention capacity. So after the today's study, how much we retain in our brain. Okay. Everybody having not same retention capacity. So I am having different. You are having different. So different students, different people, they have retention capacity in their software. It is the brain GB. Okay. In the same way, different chemicals will have different retention capacity on that. They are separated. Why using the solvent which is known as what? Mobile phase on the stationary phase. So this much only you will understand because it is a very big chapter. Okay. So what is here? Is it a single? No, it is not a single color. So you can separate it by the process of chromatography. So there are some steps here. Step number one: take a thin. You make it as thin. Okay, I made it think. Okay. So please remove the K. So take a thin strip of filter paper and trace a line. Draw. DRAW. Okay. So draw a line on it using a pencil approximately 3 centimeters above the lower edge and put a small drop of ink. Okay. So if it is from sketch pen, you will get a good result. Okay. So this you can do at your house level, home level, because sketch pens are available in the market and the beakers are available in the market, filter papers are available in the market. So even if you are in the house also, you can do this work. But for this, first you go through all these techniques. Okay. So put a small drop of ink, especially from the sketch pen, at the center of the line. So let it dry. Okay. After drying, then lower the filter paper into a jar or the glass or the beaker containing water. Okay. So that drop of ink on the paper is just above the water level. I told already. Okay. So don't disturb it. Then you see the water will rise on the filter paper due to the capillary action or the surface tension, and the water takes the dye particles along with it, and it separates the colors. Already I shown in the figure once again. You can see here. Okay. So sketch pen contains two or more colors joined together. Sometimes same color are there in different shades. See, we have blue color. In blue only different shades are there. Dark blue, okay, dull blue, pale blue. In the red only sun red, okay, brick red, blood red, normal red. So it is red only, but in the red again shades are there. So depend upon that shade or the color, we can see easily different spots are formed by the solvent when it starts moving from bottom to the top on the stationary face, and then you can take out the paper and cut according to the red part you cut separately, blue part separately. So in this way we can separate the components of a mixture. Just have an idea. So this is a simple chromatography using the filter paper. So in the left side, drop is ink spot is kept here, whereas at the right side you can see clearly the different colors are separated using the chromatography technique. This you will do in the biology practicals when you enter the 11th or the 12th class. Don't worry. Why? So what is chromatography and how does it work? Just have an idea. So this is extra for you. It is not there for your syllabus. So just have a glance. So chromatography is is a process for separating components of a mixture. To get the process started, the mixture is dissolved in a substance called the mobile phase, which carries it through a second substance called stationary phase. This already I told, so have an idea. So the different components of the mixture travel through the stationary phase at a different speeds. Why different speed? Because one is more soluble, one is less soluble. So depend upon the solubility or retention capacity. So they will move fast or slow. Okay. causing them to separate from one another. So the nature of the specific mobile and stationary phases determines which substance travel more quickly or slowly. Okay, and is how they are separated. These different travel times are called, are termed as, are known as retention time. Okay, how much that chemical is retained with that mobile phase, that is called as the retention time. That means a particular chemical is it spending more time with that mobile phase or less time or not at all. So that will determine the separation techniques here. So in this way, we have learnt the separation techniques. Today we learnt sublimation and the chromatography. Many more are there. So we learn all these techniques in our next session. That is tomorrow. So now it is saying in 2 minutes it will wind up, it seems. Okay, WebEx. So any doubts in 2 minutes? I am ready to solve. So most welcome.
Sir, which is the lightest color?
Lightest?
Color.
It's not called light or heavy here. It is called a retention capacity. Okay, the one which will retain, you can take it as a heavy. The one will not retain, you take it as a light.
Sir,
Okay, in that way you can take.
Sir,
Not
what
as
is scientific name
Does
of
not
dry ice, sir?
one. If one is speaking,
Scientific,
sir.
keep quiet.
scientific name of dry ice, sir.
Solid carbon dioxide.
Sir, in chemistry, black and white are not colors, sir.
Uh-huh. Mhm. Complete absorption or complete what emission, that is taken in the chemistry. Next.
Sir, if we do chromatography at home, it will work, na, sir?
Definitely simple. You go for simple chromatography just to understand. Okay.
Okay, sir, I will do today, sir.
Please try. Extra you will have in the, anyway you are doing the laboratory. Okay.
Okay, sir.
So okay, right. Next.
Sir, we can do with normal paper or only filter paper?
Uh, See, what is the difference between the
Can
normal
we do
paper
with
and the?
tissue paper?
Yeah, definitely. Yeah, the paper which can absorb water easily. It is filter paper or tissue paper, not normal paper. Okay, normal paper will not have that much pores. So it is having a fine pores, and it will that it is it absorbs water. Okay, so because of that we use either filter or tissue paper. Next, I think it is 9:10. So we will wind up. So remaining part we will discuss tomorrow. Thank you, my dear students.
Thank you, sir.
Thank you, sir.
Have a nice day, sir.
Oh,
Have a nice day,
have a
sir. Bye,
nice day to
sir.
all. Okay, very
Hi,
good.
sir.
Bye, sir.